So here we have, let's say, a triangle ABC, and we are going to shoot it by using the law of cosines. Then the cosine of angle A will be given by b squared plus c squared minus a squared over 2bc. Similarly, we can also define cosine of B and cosine of C. So in a sense, if the sides of the triangles are given to us, then we can easily find the cosine of the three angles. So let's begin. For this, we'll have to consider three cases. That means in each of the cases, we're going to consider the triangles: an acute angle triangle, an obtuse angle triangle, and a right angle triangle. So let us begin with the first one, an acute angle triangle. So we have an acute angle triangle ABC. Now what we'll do, we'll define its side. We have angle A. The side opposite to it is BC. We're going to represent it by the letter A in lowercase. Then we have angle B. The side opposite to it will be AC, and we'll represent it by the letter B in lowercase. And then we have the third side, AB. It's the side opposite to angle C. So we're going to represent it by the letter C in lowercase. We are also going to do one construction here. So what we'll do, we'll drop a perpendicular from the vertex A on BC, and we're going to name the perpendicular as AD. Fine. Now what we'll do, we'll consider the triangle ABD. Now let's consider we have two triangles here, two right angle triangles, ABD and ADC. So we'll consider in right triangles, the first one being ABD. So here we're going to apply the Pythagoras theorem. So it states that AB squared, which is the hypotenuse, so hypotenuse squared will be equals to AD squared plus BD squared. So we're going to label this as number 1. Then we're going to consider the second triangle. So we have the other right angle triangle, which is triangle ADC. So here also we can apply the Pythagoras theorem. Then in this case, we'll get AC squared. So that will be equals to AD squared plus DC squared. So let this be equation number 2. Now let's start with number 1. So we have equation number 1. So we are going to use it. So we have AB squared equals to AD squared plus BD squared. Now here we have BD squared. So BD is this length. Now what we'll do, instead of using BD, we can also represent BD as, we'll take the entire length BC and we are going to subtract DC from it. So we're BC minus DC whole squared. And now let's expand the second term. So we have AD squared added to BC squared minus 2 times BC times DC added to DC squared. Now we have AD squared added to DC squared. So if we take AD squared and add it to DC squared, so we know that we have already defined it. So that's value is AC squared according to equation number 2. So we'll be left with the remaining terms, which will be BC squared minus 2 times BC times DC. Fine. So we'll replace AD squared plus DC squared with AC squared. So we have AC squared plus BC squared minus 2 times BC times DC. Now we're going to define the value of DC. Now let's consider the triangle ABD. So in triangle ADC, we're going to consider the triangle ADC. So here let's define the cosine of angle C. So cosine of angle C, so that's the ratio of, we have the base, which is DC, over the hypotenuse, which is AC. So that means the value of DC can be also expressed as the product of AC with cosine of C. So here we can replace the value of DC with AC times cosine of C. Now why we have done this? Because now we can replace the value of all of the sides with the respective letters in lowercase. So AB will become, here we have taken AB as equivalent to C. So we have C squared equals to AC squared. So that's B squared. So we have B squared plus BC, which is A squared, minus 2 times BC. So BC is A multiplied to AC. So AC is B times cosine C. Now when we solve for cosine of C, so we're going to get cosine of C will be equals to B squared plus A squared minus C squared whole divided by 2 times AB. So here we have defined the cosine of angle C. So similarly, what we can do, we can use this method to find out the value of the other cosine of the other angles, which I'm leaving as an exercise for you to try out. So let me write it down. So cosine of A, it's very easy to remember. So if we have cosine of A, that means the side that will start with will be B. So we have B squared plus C squared minus A squared. So A represents the side opposite to angle A, whole divided by 2 times BC, and cosine of the third angle, which is cosine of B, so that will be equals to, since we have angle B here, so we're going to start with the remaining 2 sides and square it and add it. So we have C squared plus A squared minus B squared, whole divided by 2 times CA. So these are known as the law of cosines, and in this case we have considered an acute angle triangle. Let's go to the next case, and this time we're going to consider a obtuse angle triangle. So this time we're going to consider the triangle ABC is an obtuse angle triangle. So let's consider the triangle ABC. So here we have triangle ABC. So clearly we can observe here that angle C, that's an obtuse angle. Now what we'll do, we'll have to do a construction here. So from point A, or from the vertex A, we're going to drop a perpendicular, and we are going to extend BC to meet the perpendicular at D. So here this is AD perpendicular to BD. And now clearly we have 2 triangles here. 2 right angle triangles, one is ABD and the other right angle triangle is ACD. So let's consider both of them. So in right angle triangle, so first let's consider ABD. We have ABD. So using the Pythagoras theorem, so here we have AB squared. AB squared will be equals to the base squared, which is BD. So we have BD squared plus the perpendicular square, which is AD. We're going to label this as equation number 1. Then we have the other right angle triangle. So in right angle triangle ACD, so here AC squared, so that will be equals to CD squared plus AD squared. So let this be equation number 2. So we will be starting with equation number 1. So let's start with equation number 1. So here we have AB squared, that's equals to, we have BD squared. So BD can be also expressed as BC plus CD whole squared plus AD squared. We're going to expand it. Expanding it is going to give us BC squared plus CD squared plus 2 times BC times CD plus AD squared. Fine. Now what we have CD squared added to AD squared, so we can replace with AC squared as given in equation number 2. So we're going to get BC squared plus AC squared. So we'll combine the second and the fourth term, and we're left with the third term, so which is 2 times BC times CD. So this is the value of AB squared. Now we'll also need to define the side, so let's also do that. So this is angle A, the side opposite to angle A will be BC, so we're going to represent BC with the letter A. Then we have angle B, the side opposite to it is AC, so this side that's going to be AC, defined by the letter B in lowercase, and the third side AB, so that's going to be C. So that's the side opposite to angle C. Now here we have defined the value of AB, so that can be replaced with C squared. BC will be A squared, and AC is also there. Now we'll have to take care of CD. Fine. So to find out the value of CD, what we'll do, we'll consider the triangle ACD. Now in triangle ACD, so here we'll have to take cosine of angle C. So cosine of angle C, that means actually this angle ACD. So that's the cosine of angle ACD. So this will be defined as the ratio of the base, which is DC, over the hypotenuse, which is AC. So that means CD or DC. So CD will be equals to AC times cosine of angle ACD. But actually we do not need this angle ACD. We actually need the angle ACB, which is the original angle C. Now that means we can define it as 180 degrees minus angle C. Now what's cosine of 180 minus C? We know that that's value is negative cosine C. So we're going to get negative AC times cosine of angle C. So this is the value of CD. So let's replace it here. Now we're going to get BC squared plus AC squared minus 2 times BC times, in place of CD we're going to have AC times cosine C. Now this is the value of AB squared. So let's replace all the value with the corresponding side. So AB, we have defined AB as C squared. So C squared will be equals to BC. So BC is A squared plus AC. So AC is B squared. Minus, we have 2 times BC. BC is A multiplied to AC. So that's B times cosine C. So if we write in terms of cosine of C, so we're going to get A squared plus B squared minus C squared divided by 2AB. So we have obtained the same result as we did for the earlier case for the acute angle triangle. So that means the law of cosines also holds for the obtuse angle triangle. Similarly, we can also define cosine of A using the same technique. All we have to do is change the vertices accordingly. So cosine of A will be equals to B squared plus C squared minus A squared divided by 2BC, and cosine of B, so that will be equals to A squared plus C squared minus B squared divided by 2AC. Okay, now we'll go to the final case where our triangle ABC is a right angle triangle. Now let's say we have a right angle triangle ABC, but we're going to consider that angle B is right angle. So we have ABC. Now clearly using the Pythagoras theorem, we'll also have to first state the sides. So we have sides A, B and C. So here we have B squared. So that will be equals to A squared plus C squared. Fine. Now what we're going to do, we're going to do a manipulation here. So here we are going to subtract 2 times A times C times cosine of angle B, because we know that B is pi over 2 radians or 90 degrees, and cosine of pi over 2, that's 0. Cosine of pi over 2 is simply 0. So that means this extra term that we have subtracted from A squared plus C squared is not going to affect the original equation. But this is done because now we know that we can rearrange it to find out the value of cosine of B. So cosine of B will then be equals to A squared plus C squared minus B squared divided by 2 times AC. Fine. So we can also get the similar result for a right angle triangle. This is known as the law of cosines. So let's try to apply the law of cosines to work on few problems. So here we are given a triangle ABC. So ABC could be any triangle. It could be an acute angle, obtuse angle, or even a right angle triangle. So here using the law of cosines, we need to show that A times B cosine C minus C cosine B equals B squared minus C squared. So let's do that. So we'll start from the left hand side of a given problem. So on the left hand side we have A multiplied to B cosine C minus C cosine B. So let's multiply it. So we get A times B times cosine C minus we have A multiplied to C times cosine B. Now what we're going to do here, we're going to multiply each terms with 2, but we'll also have to divide by 2. So we have half multiplied to 2 times AB cosine C minus 2 times AC cosine B. The reason why I've written in this particular fashion, because we know that cosine C, that's defined as since we have angle C here, so we'll get B squared plus A squared minus C squared on the left hand side, and it's divided by 2 times AB. So if we cross multiply it, so we're going to get 2 times AB multiplied to cosine C. So this will become equivalent to B squared plus A squared minus C squared. So we're going to use this in place of 2AB cosine C. Similarly, we can also define cosine of B. So cosine of B, so that's equals to A squared plus C squared minus B squared over 2AC. So let's cross multiply it. So we get 2 times AC times cosine B. So this will be equals to A squared plus C squared minus B squared. So this will be equals to half multiplied to So we have 2ab cosine c, so that's b squared plus a squared minus c squared. And we have negative 2ac cosine b, so that's negative a squared minus c squared plus b squared. So we have a squared and negative a squared cancelling out, and we are now left with half multiplied to 2 times b squared minus 2 times c squared. So we can factor out 2, and we are left with b squared minus c squared, which is the expression on the right hand side, hence proved. So let's move on to the next problem. So here we have another triangle ABC, and using the law of cosines, we need to show that the following expression is true. So let us begin. So we'll start from the left hand side of our given equation. So here we have cosine of A over A. So first what we'll do, we will replace the value of cosine A with A squared, we have B squared, because B squared plus C squared minus A squared divided by 2 times BC. So here we also have division by A, so we're going to get ABC. Now coming to the second term, we have cosine of B over B. So cosine of B will be C squared plus A squared minus B squared divided by 2 times AC, and we also have division by B, so we're going to get 2 times ABC in the denominator. And finally for the third term, we have cosine of C, so that will be A squared plus B squared minus C squared whole divided by 2ABC. So since we have a common denominator, so we can combine the three fractions. So we get 2ABC as the common denominator. In the numerator, we have B squared plus C squared minus A squared added to C squared plus A squared minus B squared, and plus A squared plus B squared minus C squared. So we have positive B squared, negative B squared, positive C squared, negative C squared, negative A squared and positive A squared cancelling out, and we are only left with now A squared plus B squared plus C squared in the numerator whole divided by 2ABC, and this is the expression on the right hand side. So we have successfully proved that the left hand side of the equation is equals to the right hand side by using the law of cosines. Let's move on to the third problem. So this is problem number 3. Here we have a triangle ABC. We need to show that 2 times BC times cosine of A plus 2 times CA times cosine of B plus 2 times AB times cosine of C equals A squared plus B squared plus C squared. We'll start from the left hand side. So here we have 2 times BC multiplied to cosine A. So cosine A can be also expressed as, now, well, let's come to the definition. So we have cosine of A, that's given by B squared plus C squared minus A squared whole divided by 2 times BC. So if we cross multiply, so we get the value of 2 times BC times cosine of A. So that will be simply equals to B squared plus C squared minus A squared. Similarly, we have cosine of B. So that's equals to C squared plus A squared minus B squared whole divided by 2 times CA. The cross multiplication gives us 2 times CA times cosine of B. So that will be equals to C squared plus A squared minus B squared. And finally, we have cosine of C, which is equals to A squared plus B squared minus C squared whole divided by 2 times AB. So we get 2 times AB multiplied to cosine of C, giving us the value A squared plus B squared minus C squared. So that means we can replace 2 times BC times cosine of A with B squared plus C squared minus A squared. Then the second term, 2 times CA times cosine B, so that will be replaced with C squared plus A squared minus B squared. And the third term, 2 times AB times cosine of C, will be replacing with the value A squared plus B squared minus C squared. Fine. So clearly, few of the terms will get cancelled out. So positive B squared, negative B squared, positive C squared, negative C squared, and negative A squared, positive A squared cancels out, leaving us with the expression on the right hand side, which is A squared plus B squared plus C squared. Hence, we have successfully shown that the given equation is true by using the law of cosines. Let's move on to the next problem. Here we have to prove that B times C cosine A minus A cosine C equals C squared minus A squared. Let us begin. So we'll start from the left hand side. So first let's multiply B with each of the terms. We have BC times cosine of A minus BA times cosine of C. So we'll start with a definition of cosine of A. So that's given by B squared plus C squared minus A squared whole divided by 2 times BC. Now we're going to cross multiply BC with cosine of A. So we have BC times cosine of A. That would be equals to B squared plus C squared minus A squared divided by 2. Now we'll define for the value of angle C, cosine of angle C. So that's given by A squared plus B squared minus C squared whole divided by 2 times AB. So multiplying both sides with AB, so we get AB times cosine of C. That will become equals to A squared plus B squared minus C squared whole divided by 2. So let's substitute these two values. So we're going to get B squared plus C squared minus A squared over 2 minus BA cosine of C. That will be equals to A squared plus B squared minus C squared over 2. So that's equals to, we can combine them since we have a common denominator. We're going to get B squared plus C squared minus A squared. Now we have minus of A squared plus B squared minus C squared. So we get negative A squared minus B squared plus C squared. So a few of the terms will get cancelled out. So here we can see that positive B squared and negative B squared cancels out, leaving us with 2 times C squared minus 2 times A squared in the numerator whole divided by 2. So if we factor out 2 from both numerator and the denominator, we're going to be left with C squared minus A squared. This is the expression on the right hand side. So hence we have shown that B times C cosine of A minus A cosine of C, that is equals to C squared minus U squared by using the law of cosines. Let's move on to the final problem. Problem number 5. So let's start from the left hand side. So here we have in the numerator C minus B times cosine of A. Well, we can use the definition. So cosine of A according to the law of cosines will be B squared plus C squared minus A squared divided by 2 times BC whole divided by, we have B minus C times cosine of A. So cosine of A will be B squared plus C squared minus A squared over 2 times BC. Now we can factor out B and C, which now gives us, so we're going to combine the two terms within the numerator. So we have 2C squared minus B squared minus C squared plus A squared whole divided by 2 times C whole divided by, we have 2B squared minus B squared minus C squared plus A squared divided by 2B. This can be rewritten as, now in the numerator we're going to get C squared plus A squared minus B squared over 2C whole divided by A squared plus B squared minus C squared divided by 2B. Now we're going to do a manipulation here. So we're going to divide the numerator with A, and we're also going to divide the denominator with A. So that means now we have C squared plus A squared minus B squared over 2CA, which is nothing but cosine of B whole divided by A squared plus B squared minus C squared over 2AB. So that's cosine of C. So this is the expression on the right hand side, hence proved.